Hey, come on in. Hope you're having a great day. In this video, we're talking about a winter pattern that could be setting up and going into hyperdrive across much of the United States after the 10th of December. We're going to be talking about winter storm potential, winter blast that could be crashing out of Canada, and something I call the mini bowling ball anti-omega pattern that could set up into the southeastern United States later on the video, so stay tuned for that one. Now, before we begin, click the subscribe button if you like a daily detailed forecast breakdowns, much more detailed than you would see on TV. We go into the depths of the elegant meteorology here on the channel here, so subscribe for that. And the first thing we're going to look at here is the upper level patterns. Now, this is very important when we're looking at long-range forecasts. Okay, if you go to around right now, it's very just kind of boring across the United States. We got this kind of this flat look. When we start getting these troughs like way up here and these ridges that you're about to see, that's when things will go into hyperdrive, when we get the meridional type of pattern. Now, there could be a little disturbance out here right now, but nothing crazy. Now, watch what happens as we head towards the 10th of December here. Look at this thing come on down from Canada. Big old wave here. This is around the 10th. This is at 1 p.m. Details are going to change a bit. You can see the troughing starting to move into the west coast, and the ridging moving into the west coast, and the troughing coming out of Canada. Your coldest air is going to be near and to the west of these troughs, okay? So that's where your coldest air is going to be setting up. You might think it's going to be in here. It's usually just over here. That's where your north winds are going to kind of come down, and your high pressures at the surface will be a little bit delayed. They'll be a little bit farther back. So just want to keep that in mind. And your low pressures are going to be out in front of it, usually early on, and then they'll kind of crawl back into the wave. But anyway, that's around the 10th. So what you expect to see is stormier conditions for the east half of the United States, colder than average temperatures for much of the north and east half, and much warmer and drier for the southwestern United States. So you can see that troughing moving in, billowing from the south. Now, as we head towards the 11th and 12th, that finally moves to the east, and your cold air will kind of move east, but won't quite get to the southeastern United States. That could change in the next, what I call the double punch here, which is coming in a second. The troughing kind of breaks down, or the ridging kind of breaks down in the east coast, or the west coast, and that kind of is going to prevent this cold air, because your troughs your ridges are going to kind of nudge your troughs, your cold air. It's going to kind of shunt it down into Canada. So it might shut off for the southeast United States around the 11th, but nonetheless cold for places like Dakotas, into the Great Lakes region, into the far northeastern United States. But as we head towards the 15th, watch what happens here. You see this little wave up here. You see this ridging coming into the southwestern United States, going to get very dry and warm again for parts of California, New Mexico, Utah, Nevada. As you can see, as we head towards the 14th and 15th here, another trough comes down, really low height anomalies, kind of a double feature. I'd like to see these two kind of merge together, or this one kind of get the heck out for a very powerful storm system. But nonetheless, the signal is there. We want to look at the signals, the pattern changes. You can see ridging kind of troughing out in the northwestern United States. I think with this pattern, as we head towards mid-month, the northwestern United States might be all right for storms, or I should say it should be good for an increase in storm activity. Southwestern United States looks to be pretty torched with boring conditions. But nonetheless, this thing happens around the 15th, so I'd expect a storm around then. And then obviously this kind of recycles and it kind of drops back down around the 16th and 17th. So there's going to be another shot of cold air around the 15th through the 17th or so in the northeast half and even the southeastern United States. As we head towards later in the month, it starts to kind of get a little bit less meridional, but just more progressive for the most part. So could change again around late month. You can see that kind of progressive look. But prior to then, around the 9th through about the 18th, 19th, you get a lot of troughing out in the east and more ridging out in the west. So that's your general pattern. Now, what we're going to do is I'm going to walk you day by day here and look at the precipitation. And then what we'll do is we'll look at the temperatures. And then what I'm going to show you is something really cool that shows how these models are performing. So stay tuned to that. Now, comment below Do you want me to make my own weather models? I've been talking about this for a while, and I've finally been kind of working on that. Haven't made as many videos because I'm trying to set something up for this channel to make things a lot easier to read and see. Comment below if you'd like that. Give me some suggestions and start some conversation in the old comments below. So what we're going to look at now is the precipitation. And I'm going to talk about the ice storm potential for the southeastern and eastern, northeastern United States because it is higher than usual. It's not certain, but it's higher than usual. Now, what we'll do is we'll fast forward this thing, and we're going to go to around the 10th. You know, you can see a cold shot here, and we'll go to the 9th here. This is going to be towards nighttime on the 8th into the 9th, and you can see a high pressure sitting up here in southern Canada, a low down here. So this has the makings of a decent storm potential, and you can see a decent batch of snow for Wyoming, Montana, the Dakotas. But the issue is this cold air is so heavy heavy and dry that it's going to kind of lower the blizzard potential and crazy snowstorm potential for the northern U.S. It's very, very fast moving. I mean, we're talking very fast. This is the 9th at 1 p.m. Keep track of this because this is the low pressure. This is near the Great Lakes. You can see that cold air is already into the United States. Your 540 line, your average temperature being kind of around freezing or so. And you can see that temperature gradient is just insane. You got 570 over here all the way up to 486. It just keeps digging into the central United States. Very fast and progressive. This is on the 9th. Now watch what happens here on the 10th. We'll go back to that in a second. But this is the 10th at 1 p.m. The low pressure on the 9th was hanging out here. And then on the 10th, at 24 hours later, it's all the way almost off the coast of Canada. And you can see this cold air is just spilling in. Very high, potent, high pressure system. Very progressive, fast-moving front. With this type of pattern, I do not expect prolonged cold air unless you're in the far, far northern United States where you're going to keep getting blasts. But for the central and southern United States, you're going to get these blasts that kind of swipe against you. You get really cold for a day, and then it warms back up. And then you get cold again. And then it warms back up, so you kind of get this double punch type of effect. But let's go back and look at the storm system real quick. As we head towards the 9th, this thing is around 7 p.m. The cold air is so progressive, and this front's so progressive that it's kind of spread out. You get a wave out here, then you get your cold front, warm front. And your cold air, your high pressure is so far north, this easterly high. And the westerly high isn't, but the easterly high is so far north that the rain snow line is really far north of that warm front. Lots of rain out ahead of it for the northeastern United States. So that really shuts off the snow potential for the northeastern United States. But you can see cold air and snow for this region. With this progressive look, and you're not going to get, your snowfall isn't going to be as heavy, but it's going to be more widespread and prolonged. And this is mostly for Canada and the far, far northern parts of the United States. As this head towards the 10th and 11th, you can see this moves into, really offshore here, and the high pressure moves in very cold air for the northeastern maybe 3/4 of the United States. Okay, so what happens here around the 15th is interesting. This is what I call the bowling ball anti-omega. Now, what in the world is that? Well, it's a name I just made up here. And I'll show you what happens. And actually, this little wave comes off out of Canada. What we're looking at, I'm going to show you the 18Z real quick, and I'm going to show you what happens here. It's been kind of flipping back and forth. You can see this little bowling ball that comes down with ridges on both sides. This is a decent setup for at least a threat of some sort of storm system for the mid-Atlantic, northeastern United States, maybe even southeastern United States, if you can get enough cold air to come down. It's kind of like the opposite. In an omega pattern, you get ridges on each side and a trough in the middle. This is just for fun here. And it's like a little bowling ball that kind of sweeps out of Canada. It's something I'm watching around the 15th. We've got the dynamics to potentially support some ice potential from about, I would say, around this region right here, kind of right here in this region, particularly farther north along this area, especially in the northeastern United States, as multiple model runs have been indicating ice potential within this region. One of the model runs earlier has had a major winter storm with major ice all the way into Oklahoma. So we'll have to watch that. They're going to change quite a bit, and I'll show you how much it has changed here in a second. But just wanted to bring that up because that's definitely piqued my interest. The dynamics are there for ice. So as you can see, as we head towards the 14th and 15th, here's that system that moves into the East Coast. Now, here it is right here, your cold front right here, another high pressure coming out. Here's that other cutoff low, kind of cut off, as you know, a little trough out here in the West Coast. And so that's going to deliver a punch of very active precipitation out here around the 14th or so of December. Here's your low pressure system here. You can see high pressure is a lot farther south. See, it's sitting up here. See how farther south that is? Your warm front's kind of up in this region right here. Cold front down here, maybe more up in this region. And you can see that rain to snow line's a lot farther south, less of a bank of rain in between north of that warm front. So you can think of your warm front like this. This is north, this is south, this is cold air, and this is your warm air. Your warm front's going to be sitting right here. And as you go farther north, you get colder and colder air. So if there's a cloud out here, it's going to be, let's say that's freezing. Let's say this is the freezing line right here. It's all snow. Let's say there's a cloud out here. It's going to be rain for the most part, except for the surface. You can see that the surface is below freezing. So you get rain above, and then the surface, it's really cold because the warm front, you know, as you go farther north, it's actually it's more elevated. So that's how you get your ice like that. That's kind of a little tip there. And you can see it's a lot farther south, and so it's a better slope. Okay, and you could get some ice with this system. So there's ice potential with that. Usually with ice storms, it does blow off the snow potential a little bit. You get more easterlies. We'll have to watch that, but you can see some snow on the backside. Lots of rain along that front. It's around the 14th at in the morning or so. And then as you head towards the 15th or so, that moves to the east. Another little redevelopment here with that you get a little cutoff piece here. Now look at that. That's dynamic cooling that's occurring in the atmosphere. Sometimes a low pressure system will sink its old cold air to the surface, and sometimes you get some dynamic cooling, especially if that precipitation is really heavy. You're going to get some latent heat release and maybe even get a little pocket of snow. This, I almost guarantee, is going to change. Sometimes the models do well with these little systems, but the location of this is going to change, and the dynamics is going to change. It's very small and subtle, but it's definitely something to watch. We'll make more videos on it in the future. That's around the 15th. That moves out around the 16th or so. And then another storm system around the 17th, 18th moves into the East Coast. It's getting pretty far out there, but it's another system to watch. But like I said, I've been looking at several different runs, several different models. The activity is going to greatly increase for this region. For giggles here, let's look at the previous run of the GFS, or a few runs ago, and I want to show you just something. This how astronomical the differences are. Again, these details, specific details, are going to change, but the activity, the signal, is what we want to look for. Okay, the details are the noise right now. But as you can see, around the 13th or so, that's that 14th storm system I was talking about. Look at the high pressure now. It's a lot more widespread. It's east to west across the United States. Your baroclinic zone, your temperature gradient, is flat across the United States, from warm in the south to cold in the north, and it's kind of evenly distributed and flat. The isobars are east to west. Okay, you can see that. Here's your low. And with that, you get this kind of stationary front that kind of develops and just kind of sits out in the southeastern United States, and you get overrunning. So what you're going to get is your mid-levels are going to be kind of out of the south-southwest that deliver moisture. So this is mid-level moisture. You don't typically get it as much from the surface in the winter. It's a little bit cold, but isentropic lift and mid-level moisture, it's going to be coming from the south and southeast. Your surface winds are going to kind of be in the east like this, and the general storm track is going to be kind of east-northeast. What does that do? Well, you can think of your warm front again. Your precipitation is going to be kind of evenly distributed along this temperature gradient, and even out ahead of it too. And there's going to be precipitation. Now, this is a terrible drawing, but nonetheless, you get your precipitation right here that's ice. So there's going to be a little belt in there where there's ice, and because it's very slow moving, and because it's kind of moving east-northeast, there could be ice for hours along that line. So it's a perfect setup for an ice storm. Again, the issue is the inconsistency and how fast and how powerful that second cold blast is, it's this winter, there's been a lot of snow up here. The pattern would support stronger, colder blasts that move into the United States. And so I'd almost say this might be a bit of a fantasy, but we'll definitely watch this. I think the other model run that we were looking at is a little more realistic, and then the European, which I'll show you in a second, is more realistic with a greater snow and ice potential for this region right here. But it's definitely something we want to watch. This reds or the oranges and purples, sleet and ice ran out ahead of it, and snow kind of out behind it. Snowstorms usually with these things aren't extreme, but they are moderate and can pack a punch. As you can see here, the ice moves into the mid-Atlantic region as we head towards the 15th and so. And that kind of breaks up into two little lows as we head towards the 16th. So something kind of interesting to watch there. Let's look at temperatures real quick. Then I'm going to show you something kind of cool. It's a cool tool. We'll look at the GFS here, and we'll look at temperature anomalies. So what I'm going to do is go over to the GEFS, because I think the GFS likes to overestimate the heck out of this stuff this far in advance. And the GFS is a more accurate blend of different model runs here. And as we head towards the 10th, you can see the 7 p.m. on the 10th, 31 degrees below average. Now, the GFS actually had 50 degrees below average up here in the Dakotas. Again, I'm going to say that's overestimated. And the GEFS is a little more realistic. Very warm conditions in the southeastern United States, but that's about to change really quick here. This is the 11th, the morning of the 11th. You can actually see almost 40 degrees below average for Minnesota, parts of the Dakotas, and Wisconsin. This has been very consistent on multiple models here, on multiple runs, and has been the pattern. If you look at the sea surface and all that, the general pattern has been, if you look at my winter forecast, to have the coldest air in this region. I said it wouldn't be cold all winter. I said there'd be a lot of temperature swings, but when it does get cold, it'll be sharp. It'll be very knifing cold air, especially within this region right here. That looks exactly like what we're forecasting for a lot of this winter here. And you can see even on Thursday at 6 p.m. or 6 a.m. on Thursday the 12th, still very cold in that region. It does die out, and I said this is going to be a pattern this winter where it kind of just dies out a bit as it moves to the east, but it still does give the East Coast cold air. 15 degrees below average in some area, generally 5 to 10 degrees below average. That heads, around the 13th and 14th. And then around the 15th, we get that second punch, that double punch, with another, again, this is still very cold, 5 to 15 degrees below average in this region from the 15th through about the 19th, and that does move into the east coast of the United States. So generally speaking here, this is where your coldest air is going to be, with an average of about 10 to 20 degrees below average from the 9th through about the 15th, 16th, maybe 18th of December. And then really this whole region right here going to be really ending up at least 5 degrees below average in that period. So very cool temperatures. What do actual temperatures look like? Well, we'll look at a couple days here, not every day, but we'll look at the 12th, and we'll look at 12Z on the 12th. Or how about the 11th here? That's going to be the coldest day. The 11th at 12Z, around 6 a.m. or so, and you can see negative 20s in some of these areas. Negative teens, 20s for parts of the Dakotas. Now, I know you're always saying, oh, it's winter, it's going to be always cold. And I get that, but we're just doing this for fun. This is still pretty extreme. I like to focus on more of the extreme stuff on this channel, but you can definitely see, here's your Arctic air mass right up here, and it doesn't change much. I mean, you go from Minnesota here up to parts of, you're getting way up into Canada, and it doesn't change a whole lot, maybe 5 to 10 degrees or so. So you can see really just the core of the air mass just sitting up here in the northern United States and Canada. And then as we head towards the 14th, I'm going to show you this kind of move off to the east. Around the 14th and 15th, it does kind of move into the East Coast as well. Temperatures still in the teens and 20s, so nonetheless very cold. The question is, well, how fast will this cold move in? Can we get a nice organized storm system that moves up, and can we get cold air on the backside for snow? And how was that ice storm potential going to be? So that's what we're going to talk about in future videos. Now, I just want to show you how different the model runs are out in advance. So what we're going to do is we're going to go back to the first run here. This is kind of measuring the 540 height line. And you can kind of see where the troughing and ridging is. You can see how everything's close together. This is the GEFS. So the GEFS takes several members of the GFS model. They change up the physics properties and the initial conditions just slightly. And they say, well, okay, if there's a little bit of error in the models or in the environmental temperatures and observations, how much will it affect the forecast? Because there's always going to be error. So this is the butterfly effect, the chaos theory, essentially. And you can see, like right now, there's not obviously much, but watch what happens as we go into the future here, as we head towards our storm systems. And we go, this is around the 9th and the 10th, and this is when our first blast comes here. You can see that main trough is going to be kind of in this area. That you can't guarantee there's a trough with one height line, but the height line is farther south, almost always going to have some type of trough here. And then you can see the ridging out here. So pretty consistent with ridging and troughing, particularly within this region right here. Very, very good chance of cold air. And as you can see, there's a little more inconsistency up here and over here. So you can kind of see where the model's inconsistent. So we could go back to the GFS maybe for another day, but go to 102 hours and then look at this region right here in the upper level and see where it's having trouble. But anyway, that's kind of a little tip there. Now, as we head towards the 10th, 15th, let's go to that storm on the 15th, and you can just see this really starts to spread out. So slight changes in the initial conditions and physics packages, slight changes could have a big impact on the weather. Could be up here, could be down here. But generally speaking, you'd want to put a line kind of in between, kind of like that, around the 14th and 15th. That's kind of what the GEFS does, is it kind of blends this stuff out. But as you can see, after about the 12th, and I would say after around the 13th or 14th is when things become a lot less clear, particularly in this region right here. Maybe a little bit of inconsistency right there, but it starts to break down really, as you can see. We'll go back right after about the 12th or 13th. So we'll have updates on that for sure. You can actually see around the 19th, there's more consistency again here. So sometimes the models will have a good handle on certain things and a bad handle on other things. And maybe it just has a good handle on this particular wave around the 19th of December. So kind of cool to look at that type of stuff. And again, this is NCEP. You can find their weather models there. It's called a spaghetti chart. So if you like that, check that out. Again, I think that's what's going to wrap it up on this video for now. Go ahead and subscribe. Comment below if you'd like to see what kind of graphics we'd like to see on this channel. Would you like to see our own custom weather models? Trying to make things more presentation friendly. And that's kind of where I've been. I'm going to be kind of busy over the next couple of weeks. Probably do more of a, couple of videos a week, just because I'm trying to get a lot of upgrades here for the channel. Could be a lot of big changes coming. So lots of big changes. So go ahead and subscribe. Stay tuned. Hope you have a great day, and we'll see you soon.